Hey everyone, this is a video on what we talked about in class about how to borrow when you subtract fractions. Now you don't always have to borrow. The only time you have to borrow, just like you borrow with whole numbers and decimals, is when the top number is too small. So in fractions, the top number that we're talking about is the numerator. Because remember, in fractions, in adding and subtracting of fractions, you have to have a common denominator. So what is actually being subtracted is the top numerator. So this page comes from your pack that we did in class called Subtraction of Fractions with Borrowing. It gives you two examples, 7 and minus 1 1/3, which is 7 wholes minus 1 1/3. That's a little unique, and so I'll tackle that second. The second example is 5 1/3 minus 2 5/6, and I want to work with that one first. Okay, so as you know, I like to write these vertically. I think they're easier to work with in fractions. So it's 5 1/3 minus 2 5/6. So the first thing that you should recognize is we have a 3 and we have a 6. So we don't have a common denominator. But method 1 asks, can you divide the smaller denominator into the larger denominator evenly? If you can do that, then you can use the larger denominator. And 3 does divide into 6 evenly. So that's good. And we like that because that's going to save us a little bit of time. That means we can use 6 because 3 does divide evenly, and that means 5/6 obviously is already in 6th, so I only have to make a conversion on top. So I'm going to ask myself, 3 times what is 6? And that is 2, and that means I have to multiply the top number by the same number, and 1 times 2 is 2. So whenever you make equivalent fractions, you have to multiply top and bottom by the same number. Okay, so now the problem is, let's rewrite this. 5 2/6 minus 2 5/6. So while I have a common denominator of 6, the problem at this point is right here. I can't subtract 5 from 2. It's not big enough. So what we can do with fractions is look at the 5 and we can borrow from it. And what we're going to borrow is 1. So if I take 1 from 5, that becomes 4. Now, I'm going to borrow 1 in fractional terms. So we can write 1 any way we want to. We talked about this in class too. As long as the numerator and the denominator are the same thing, for instance, 2/2, that is equal to 1. 3/3 equals 1. 10/10 equals 1. 50/50 equals 1. It doesn't matter as long as it's the numerator over the denominator. So because I'm in 6th, I want to write 1 in 6th. And the whole idea is to take this 2/6 and boost it up. So I'm adding 6/6 because, again, I took 1 over here from the 5. So 4 and 6/6, which equals 1, brings me back to 5. Okay, so what I'm going to do is go ahead and add these two fractions. I have the same denominator, so that means I can just add them together. 6 plus 2 is 8, but let me not forget there's 4 wholes over there. And let me just slide over this 2 5/6. So, yes, they get a little messy. Hopefully this is not confusing you too much. But the problem is now 4 8/6 minus 2 5/6. So I have a common denominator of 6. The top numerator is larger than the bottom, so I can subtract. And I am good to go. So let's go ahead and subtract 2 from 4 by doing the whole numbers, which is 2, and I have my common denominator of 6. And 5 from 8 is 3, and hopefully you recognize right away that 3 6 is not in lowest terms because 3 is half of 6. That makes that one automatically 1/2. So the answer is 2 1/2, and you're done. So basically, not only is that it's not hard, but it's pretty fun. At any time when you're subtracting, if you find that the top numerator is not large enough, you can look to your whole numbers. It'll always be a mixed number if you have to borrow. And you can borrow 1 using the same denominator that you're already in to boost that top fraction. And then you can fully do your subtraction and put your answer in lowest terms. Okay, now let's talk about what happens when you have a whole number. Okay, and again I want to write this vertically. So I have 7 minus 1 1/3. So as you can see at this point, I can't subtract 1/3. There's nothing there above it. There's just whole numbers and there isn't a fractional part. So what we want to do is convert that 7 into a mixed number, and we're going to do it the same way, by borrowing. We're going to look to the 7, and we're going to borrow 1. So in this case, 1 from 7 would leave me 6 on top, and I want to write 1 this time in thirds. I'm actually not, I don't have a fraction up there to boost, I just want to write 1 in thirds. And to write 1 in thirds, well, 3 over 3 is equal to 1, because I took 1 over here. So let's go ahead and do that. Let's put 3 over 3. And now the problem is 6 3/3 minus 1 1/3. And I have a common denominator, and the top number is higher. To subtract the top numerator, I can subtract from. So I'm good to go. And let's subtract the whole numbers. 1 from 6 is 5. I have a common denominator of 3. And 1 from 3 is 2, and we know automatically, that's my favorite, when it's the numerator is 1 less than the denominator, you're automatically in lowest terms. So that wasn't too hard at all. In this case, we didn't have an existing fraction on top to boost. All we did was borrow 1, and we made it a mixed number. We essentially took 7, and we made it 6 3/3. And if you're asking yourself, is that legitimate? Yes. Let's convert it back. We know how to do that. I mean, we can convert any mixed number to a whole number or a fraction by multiplying 6 times 3 and then adding 3. So 6 times 3 is 18, and 18 plus 3 is 21 over the denominator. And 21 divided by 3 is 7, because 7 times 3 is 21. So 6 3/3 is actually an equivalent to 7 wholes. Okay, so borrowing is fun. Borrowing 1 and putting 1 and adding it to a fraction, or just making it a mixed number using the same denominator that you're already in. That's a really fun concept, and if you practice this, I think you'll find that it's an interesting way to subtract. However, you do not have to go through this borrowing technique if you really don't like it. I personally would prefer that you do it because it tells me a lot about your fractional skills. But I will say, if at any time you're working with a fraction and the top number is not large enough, you can turn all of your fractions into improper fractions, and in almost all cases the top number will be higher, so you'll be good to go. So let's go through those examples and let's change these all to improper fractions. Okay, so in the first example, I wrote this vertically, and I changed my whole number 7 to 7 over 1, and then I'm subtracting 1 1/3. So 7 over 1 is already an improper fraction. I just need to make the bottom one improper. So let's go ahead and do that. 3 times 1 is 3, plus 1 is 4, so that's 4 over the denominator 3. Now you can see automatically I do not have a common denominator, and that means I have to find one. Obviously, 1 does not divide into 3 evenly, so that doesn't work. So basically, we're just going to multiply the method number 2, multiply the denominators, 3 times 1, and we'll get 3, and we'll make the conversion. Whenever you have a fractional problem and one denominator is 1 and the other one is 3, your common denominator is always your largest number. It's the same thing as multiplying them together. 1 times 3 is 3. So now let's make the conversion to equivalent fractions. This one, the bottom one's already done because we're already in thirds. 1 times 3 would give me 3, so 7 times 3 would give me 21. So I've essentially converted this problem now to all improper fractions. Be careful when you do this. That means this is gone. Don't try to put that back into the problem. The problem changed to 21 over 3 minus 4 over 3. So I have a common denominator of 3. I'm good. And the top number is larger than the bottom number, so we're good to subtract. I'll put 3 as my common denominator, and 4 from 21 is 17, and that is an improper fraction. If you have 17 over 3, make a fraction house. 3 goes into 17 how many times? Well, 3 times 4 is 12. 3 times 5 is 15. 3 times 6 would be 18. That's too much, so we'll use the 5, which is 15. And that's 2 is left over. And that you would write as a fraction over the divisor. So the answer is 5 2/3. And we know that is correct because we just did it using the borrowing method a few seconds ago. Okay, now let's take a look at the second fraction, 5 1/3 minus 2 5/6. If you know that you don't have a common denominator, so we would go ahead, we know from doing this problem earlier, we can divide 3 into 6. So we know that we can use the larger denominator of 6, and that means this one's already done. 5 6 is already in 6th, and that also means that we only have to convert the top fraction. So 3 times 2 is 6, and 1 times 2 is 2. So again, I see that I have a problem here because I can't subtract 5 from 2. So another method is to convert all of these, to just sort of throw this out and convert them all to improper fractions. Now, you could convert them from the existing fractions, or you could do it from here using the fractions with the common denominator. If I rewrite the problem, I would have 5 2/6 minus 2 5/6. I would probably make them improper from here because I already have my common denominator, and that'll make it a lot easier. You can also do it from the beginning, but you didn't know from the beginning that that your top number wasn't going to be large enough. So typically that's where you're going to find yourself, is here, right here. And at this spot, you can go ahead and make them improper. So let's do that. 5 times 6 on the top one. 5 times 6 is 30 plus 2. So that would make this 32 over 6. And the bottom, 2 times 6 is 12 plus 5 is 17 over 6, and that's subtraction. So I have a common denominator of 6, and 15 from 32, I'm sorry, that's 17. Sorry about that. 2 times 6 is 12, plus 5 is 17 over 6. So I have my common denominator, and 17 from 32 is 15. Whenever you convert fractions to improper, you're almost always going to get an improper answer. And you can't leave it like that. You have to divide that out, or you can simply ask yourself, 6 goes into 15 how many times without going over? Well, 6 times 2 is 12, and 6 times 3 is 18, so it would be 2 times, which is 12, and if I take 12 out of 15, there's 3 left over. 2 and 3/6, and we know 3/6 is automatically 1/2, so it's 2 and 1/2. Or, whenever you have an improper fraction, you can make the fraction house, if that's easier for you to see. So again, 6 goes into 15 2 times, because 3 times would be 18. 6 times 2 is 12. That would leave me with 3 left over, and I'm going to write that as 3 over the divisor, and that's not in lowest terms. It's 2 and 1/2, because 3 is half of 6. And we already did this problem using borrowing, so we know that the answer is 2 and 1/2. Okay, so I hope that you found this to be a helpful video. If this is still sticky for you, I would invite you to go ahead and watch this video as much as you need to, but it's a great concept, and I think you'll really enjoy borrowing. So I'll see you in class.